So recently I've been experimenting a lot more with geometry nodes to create these little visual effects that can just breathe life into a scene. And I've found that I'm using pretty much the same simple node setup through 90% of them. So in this tutorial, I'm going to share how I used a version of that node setup to create this comic book inspired animation loop. And because geometry nodes can be pretty overwhelming, especially if you're unfamiliar, I've tried to keep this as beginner friendly as possible, breaking down as much of the process as I can, from modeling the shapes and properly preparing them, to creating a randomizing material, and then each stage of creating this completely custom modifier using geometry nodes. If you want to follow along, you can download the project file from a link in the description, which includes the TV model and a sticker texture sheet that you can use in this and other projects. And if you are familiar, you can always jump ahead to the animation section where I break down this method in a bit more detail. If you do enjoy the video or have any questions or feedback, please leave a comment. Otherwise, let's get started. So with a fresh scene open, the first thing we want to do is start modeling these kind of really angular comic book inspired shapes. And they'll start with a mesh plane. So Shift A, mesh plane, and switch into edit mode. And we can just start grabbing vertices and moving them around until we get shapes that we like. You can be really loose here. You don't have to nail this. The main thing you need to pay attention to is just where the pivot point is, so where your origin is. Where it is at the moment, it'll be rotating and scaling around the center, whereas what we ideally want is that to all happen from the very base of the shape. So to fix that, in edit mode, I'm going to hit A to select all my vertices and just roughly position it where my origin point is. This doesn't have to be perfect, but if we do want to be precise, then we can just select the vertex where you want the pivot point, Shift S to snap the cursor to selected. You see the cursor's jumped now to that point. And if I tab back into object mode, I can right click and set my origin to the 3D cursor. Now my origin is where my 3D cursor is, and it's behaving properly. Once we have the first shape that we're happy with, back in object mode, select it, Shift D to duplicate, and back in edit mode to just keep nudging things around. It's good to have a mix of size and form though, and we'll see that the reason why later on when we get into the animation, but try and make these as different as possible. It's always a good idea when working with geometry nodes that you prepare the objects you want to bring into your geometry node setup in a way that's just going to intuitively make sense to you later on. And so if I'm looking at these shapes and up at the gizmo, they're flat on their backs with their heads towards the Y direction and they're facing up towards the sky. Whereas what makes the most sense, if I was to select them, I'll hit R to rotate, X to snap them on the X, and 90 to snap them to 90 degrees. For me, this makes the most intuitive sense as their default position because they're standing up towards the Z axis, they're facing away towards the Y, and their left to right is X. You always have to make sure you apply transform. So if I Control A, if I apply that rotation now, that's applied it as their base rotation. This is their default state. And we'll want to do the same with the scale. If you've downloaded the project file, then you can bring in the television as a reference point, which is what I'll do next by hitting Shift A down to collection instance, and I'll find my television set here. So I just need to make sure that I roughly scale them down and get their proportions loosely right in comparison to the television. Same again, once you're happy, Control A and apply the scale this time. We'll use a TV in a second, so let's just hide that. Let's organize our scene a little bit. Control F2 will bring up our battery name. And if we change it to set name and new, call it flash 1. I'm adding this suffix here, so when I hit OK, the first object in my collection starts with 1, and it will automatically update the number for each new object in that collection. Let's actually add them to a collection. So if I hit M, create a new collection, call this flashes. Perfect. Now they're nicely organized, ready for later. Before jumping into geometry nodes, let's give them a material just to make them more interesting. I'll drag this panel up here and bring up my shader editor. Let's select one of our shapes, switch into rendered mode so we can see what's happening a little better. And I'll create a new material and call that flash. Okay. We won't need any of these things like metallic or roughness. We just want the emission. So if I search emission, and an emissive material is a material that just produces light, doesn't reflect or react to light at all. I'll connect that to surface. And to apply this material to the rest of my objects, drag select those. Now they're all highlighted, and I'll shift select the object I want to take the material from. You can see that now this is the active object. It has this different colored outline. If I control L, link materials, it's now transferred the material from this guy onto the rest of my objects. I can see that by tweaking the color. Excellent. Next thing to do is randomly assign a different color to each object, but we don't want to have to create a separate material to do that. We want to do it all within a single material. And so in the shader editor, the node for that is the object info node. Basically, this node stores unique information for each object you've applied the material to. So even if you've got one material, for each object that has it, it will give different information for each of these sockets. The one we really care about is this random output. And this output randomly generates a number between 0 and 1 for each object. And we can see that in practice by connecting it to the color here. And you can see straight away each one of our shapes has a different grayscale value between 0 and 1. 0 in shader world, 0 being black, white being 1, and basically grey being all the values in between, which is actually exactly how a color ramp works. So let's bring a color ramp in. And so if I take my random value and put it into my color ramp instead, and then take the output and put it into color, nothing happens. So if I mute this, there's 0 change. And that's because currently it's mapped to the same range. So 0, if I click on it, is black. White is, the last stop here is white, which is 1. But if we were to change these two colors, depending on the value that each shape is getting, it will have a different color picked from this selection here. So now if I start to duplicate these, every new duplicate is its own new object. We'll see that in the flashes. So as I'm adding more, you can see that's adding more to my collection. Each new object that has this material gets a different color. The only problem we now have to fix is that we're getting these kind of muddy, desaturated tones in between these colors. And that's because just by default the color ramp is trying to smooth out as best as it can from one value to the next. And to change that, we can just bring this drop down up. And these top 4 are different smoothing or interpolation methods. We don't need any of those. We just want to switch to constant, which will give us these very hard stops. So depending on the value they're getting, they'll only ever fall within a complete solid color. And so the more stops you add here, the more variety you'll end up with in the final result. I'm happy with these for now. We can always come back in and noodle later on. But before we get into geometry nodes, let's make our shapes glow with some bloom. Since Blender 4 and above, you're not going to find bloom in the Eevee render settings. You'll have to drag in a compositor. And if I bring up the compositor here, if you're not seeing this graph, just make sure you have use nodes checked. And this works just like any other graph that we're used to in Blender. So we have an input, output, and we can do all kinds of stuff in between to manipulate that. For us, we just need a glare filter. And this is where you'll find bloom now. So if I open up this drop down, I can bring in a bloom effect. And we won't see anything for 2 possible reasons. One is if we go up to the viewport shading, you need to make sure that the compositor is always displayed or only displayed through the camera, whatever you prefer. Let's do always for now. And the second is because bloom has a threshold, which is at what point do I kick in? And at the moment, it will only kick in above 1. And so if I look at my emission, it's too weak. So I need to just add a slightly higher value to my emission. And now I'm getting some glare. So we can maybe try 1.2. Maybe just a touch more. And you can also play with things like the quality of the bloom. The mix, so how much is basically mixed in with the original image. And leave that at 0. And then also the size of it. And I'm just going to just totally overdo it, crank this up to 9. Okay, I think we're ready for geometry nodes. Let's close up the compositor and bring up the geometry node editor. Just before we jump in, let's do a quick recap. Essentially, it's all built off a curved circle, which we can position anywhere in the scene. In this case, we're putting it in front of the TV. And then around this curved circle, we'll create points. And on those points, we can duplicate the shapes that are in our flashes collection. And these duplicates, these copies, they're known as instances in geometry nodes. So we can instance our shapes. And then once they're on the points, we can start to animate things like their distance, their movement, their scale, rotation. But it all essentially starts off with that single curve. With our television in the scene, let's Shift A, add a curved circle. And just like our flash shapes, we'll rotate it so it's in a position that makes sense. Rather than moving my curve, I'll move the TV. I want to keep the curve at the world origin. So I'll move my TV out of the way instead. And actually I can see that my cursor isn't actually at the world origin. So I'll Shift S to snap the cursor to world origin. And then with my circle still selected, Shift S to snap my selections cursor. And now that's in the center of the world. I can start scaling this just so it obscures my TV screen. Just want it to sit roughly within this space here. Feels okay. Okay. And again, once we've changed the rotation scale of an object, we need to apply it. So Control A, apply the scale. Same again with the rotation. With my curve selected, I'll switch into the geometry node editor. It's already up. I'm also going to bring out the modifier panel just so we can see what happens. So when I click new, I'll get this really simple graph created and a geometry node modifier added to my modifier stack. Just like the compositor, just like the shader editor, we have an input. In this case, it's our geometry, our curve, and then we have the output that comes out the other side. What's especially cool about geometry nodes is they are modifiers. So if I cut this and my geometry disappears, if I deactivate my geometry node modifier here, my curve reappears, and if I was to reactivate it, it disappears, as this hijacks the geometry basically. We do want our curve though. Let's reconnect that back to the end. The first thing we need to deal with is just getting our points around our curve, which is easy enough by using a curve to points node. And we can find that under the curve, operations, curve to points. Or you can search for it by Shift A and searching at the top. Or you can just drag off the socket that you want to connect to and search again. And when I add that, it automatically makes the connection. By default, the points come in really big, so we can use a set point radius to set them to a manageable size by just changing this radius size. Make them a little smaller. You can see that this curve to points has a new input for the count, and if we change that, we change how many points we have around the curve. So that's perfect. And it also has these new outputs. And we'll dig a little bit into this one in particular later. For now, I want to expose this count and add it to my modifier stack over here, so I can adjust it every time I use this modifier. And one way we can do that is by coming up to our group input, dragging off of this socket, this empty socket, onto the input we want to expose, and as I let go, you can see it's added it to my modifier stack. If I come over to my side panel and look in my group tab, you can also see it in my group sockets here with some additional controls, things like the default setting, the minimum and max. And now if I was to duplicate this geometry which has this modifier applied to it, I can change this input individually. So they're not shared across the modifiers. We don't need that for now. Let's delete that, back to our original curve. And now the next thing we need to do is instance our flash objects on each point of our curve. I'll take it down for now, so it's a bit more manageable. And the node we need to place things on points is the instance on points node. If I drop that on, everything's disappeared, because for this to work properly, it needs something plugged into both the points and the instance inputs. For the second input, let's drag in the flashes collection. And you can either drag from the outliner, or you can right click and use a collection info node directly. And that's the same node. And from here, you can search for collections in your project. And this will look across scenes. So even though the television set isn't in this scene, I can access it from here and drop it into my project. Let's disconnect that. Now if I drag the instances off of here onto the instance on points, by default, when you instance a collection, Blender's assuming that you want to keep it as one whole object. Imagine you've modeled a car, and each part of that car is a separate piece of geometry. So the headlight, the doors, the wheels, all of those are different meshes, and you've just put them in a collection, and you want to drag that into geometry nodes and used as just one whole object, which makes sense a lot of the time. But in our scenario, we actually want it to look in the collection, the flashes collection, and say, actually, everything in here is its own individual object. And we can do that by hitting separate children. We also need to reset the location. It's still referencing wherever the flashes are in the world is kind of where it's referencing them. So reset. So now what we're seeing is every object from this collection is being placed on each individual point. So we can pick them individually. Let's hit pick instance. Now it's only taking one object at a time. But if we open up this guy here, and let's add a few more points to this. We can actually just see it's just going in order through the collection at the moment. And then when it gets to the end, starts again. To randomize things a bit, because this will become even more noticeable as we start to add more points, or as we duplicate this modifier and reuse it. So ideally what we want is to let this know that we want it to randomly pick for each point. And we can do that by plugging into this instance index. An easy way to think of what an index is that anything coming out of any of these green sockets is added to a numbered list starting from 0. And in the case of a collection with multiple things, then each number goes up by 1. And so we just need to pick randomly from that list of numbers. And we can do that with a random value node. And this is much more powerful than the one you get in the shader editor, because you can change the data type, which is represented by the different colors of these sockets. And for the instance index, that has this kind of forest green color, which is an integer, which is a whole number. You can also change the range, so you're not just fixed to putting out values between 0 and 1. You can change what your minimum and max is that you get. So let's connect this up to the instance index input. You can see that all the shapes now are randomized. And if we want to change the selection of shapes, we can just cycle through our seed here. And so in principle this works because we have a very high max value and there's only 7 objects in the collection. To have it work properly so that it only pulls in a maximum range from the amount of objects that are in here, we need to do a little bit more complicated setup. And so what we need is a node that can look inside our collection, check the column that has the index number in. So we need to look in the collection, check this index list, and then out the other side, tell us what's the minimum number, what's the maximum number in that column. And we can do that with an attribute statistic. And if we connect the instances output to the geometry input, then search for index, that's the attribute that we want to get information about. Plug that into attribute. And to get this to work properly, you can see this drop down here, which is the domain drop down. And if we look up at our collection, we can see it actually says instances on the output. So we just set it to instance. And now this has everything it needs to give us the right minimum and maximum values. And if I tab through that, that's working correctly. And if I add more objects to my collection over here, it'll automatically update. So now that's just set and forget. We don't need to worry about that. The next thing we need to look at is the fact that they're all standing upright. So they're all matching how they're currently rotated in the world. Whereas what we want is them to fan out around this curve. And we could do that by using an align rotation to vector. And we can use this to align our shapes to a vector from the curve. First, let's just plug in the rotation to the rotation on our instance on points. And now we just need a couple of bits of information. The first is, what axis of our shapes do we want to snap? So Z goes up, X goes side to side, Y goes front to back. So which one of these are we snapping? And what's the vector, what's the purple input that we're snapping to? We want it to snap to the curve, so we want to use the curve as the thing to influence the rotation, because that's what they're sat on. And so when we look at our curve to points, we have two vectors to choose from. The best one for us is tangent, and the tangent of a curve is just at any point, what direction is it facing? Think of ants kind of walking on a hill. At any point, what is directly forward for that ant? And so if we look at our curve up here, and we start drawing roughly drawing what the tangent would look like, and then compared it to how we want our shapes arranged, we can see that this looks a lot like the x-axis. So let's see if that works. We'll drag the tangent to the vector we're snapping to. And we need to choose the x. And there we go, we're working. Okay, that's most of the tricky stuff. We're like very close to doing the fun stuff. Before that, I'm going to reset this to 1. And let's also expose that so we have access to that later. And another way of creating group inputs is just dragging off of the socket, let go, and then if you select group input, it'll automatically create a new input. In our case, we don't want individual access to each axis. We just want one value that can scale them all up together. So to change that, in our group sockets, in our group tab, under scale, I'll change it from vector to float. And float is just any value with a decimal point. So it's a single input. Set that to 1. And just in my default, I'll set that to 1. I'll also set the minimum so it can't go below 0. So just set 0 as the minimum. As I'm building out geometry node graphs, I find it really useful to color code these inputs. With that node selected, I'm going to come down to the node tab, and you can see you can highlight color, open that drop down up, and then pick a color for it. I've actually made some presets, so just going to bring my presets up, and I'll make any input blue. I'll duplicate that, make it like a separate node. Control H will hide any sockets that are not being used. And now at a quick glance, I can see where all my important inputs are in my graph. The last thing before we start animating is, at the moment they're all fanned out completely parallel with the curve. I want to be able to actually adjust the angle. So let's do that by bringing in a rotate instances. And the really powerful thing about working with instances in geometry nodes is that each of these is considered its own individual object, which means you can control the transforms of them individually. So let's expose this X rotation. We don't need the other two channels, but you can see it's only got a single socket going into that. To split that out, we'll bring in a combine XYZ. And if I drag that to my rotation there, I can now adjust this. The only problem being that if I put 2 into this socket versus 2 here, I can see the difference is huge. The rotation input works in degrees. which is I think what most people are familiar with, whereas these sockets calculate in radians. And that generally equates to pi, or pi, if you write it in a field here, is the same as 180 degrees. So if I typed in, say I want this at 90 degrees, I could type in pi divided by 2, and I've got 90 degrees there. Rather than having to manually work that out every time, if we bring in a math node, we can open up this and we can use this 2 radians, which will convert degrees to radians. So if I put in 90 into this field, plug this into that socket, this just does the conversion for you. And let's expose that by dragging off again and doing group input. Open up my group tab and let's name that angle. We can adjust these minimum and max range. So we want a minimum of 0 and a maximum of 360 degrees. Default 90 is fine, and we'll color code it. Okay, great. Let's make some space for animating. The idea now is to animate them so they move away from the curve, and then as they get further away, they get full size before shrinking again to nothing. And then they just loop like that. But I want that to be different for each one of these shapes. So let's start by animating just the main translation. We'll start by bringing in a translate instances, and we'll stick to using everything in this section here. So if we go to instances, rotate, scale, translate. They're the 3 that we really care about. So if we start to adjust the Z direction, we can see that they're still maintaining their local transformations. So the Z is still up, their X is still left to right, and that's exactly how we set them up in the first place. So let's animate this, but I don't want to do any keyframing. I want all of this to be done procedurally inside geometry nodes. The first thing we need to do actually is separate this out. We don't care about these other 2 axes. So I'll just select this combine XYZ, Shift D to duplicate and bring it over. Backspace on that to zero it out. Now I need a way of dynamically animating this value. Luckily in geometry nodes we have a scene time, and a scene time basically puts out the current seconds and the current frame. So if I drag this into the z-axis, and now I'm at 0, you can see as I drag the playhead, this is my frame number, which is coming out of here. I'll zoom out so we can see better. As I drag it, they get further and further away. Hit play, we animate. This is quite intense, so just to kind of soften that effect, I'll bring in a math node and divide it. So each frame, let's divide it by, I don't know, 10. So now it's only going 0.1 every frame. Now it's a bit more gradual. So now, if we were to draw this as a graph, we have the time at the bottom. That's our timeline. So we've got 0 to 250 frames, let's say, at the end. Along here is the distance they're traveling, which is going to the Z. And as I play it, as the time goes up, they get further and further away. So that's what the animation graph looks like. But really what we want is a looping animation. So we want them to be able to go a certain distance away and then start again and continue to loop across the timeline. And so we want to be able to firstly set the length of that loop, like how many frames do we want to include? Does it loop every 25 frames? And we want some control over that distance that they're traveling. So maybe they only go 2 meters. And once we've got that worked out, we need a way of making all of that random for each object, so they're not all behaving in a way that feels like uniform and consistent. First of all, let's tackle the loop. And the easiest way to do that is by using another math node. So I'll Shift D this and bring up the options, and I'm selecting truncated modulo. And a modulo is essentially a looper or a repeater. If I put in 25 in here, this should loop the incoming frame value. So when it hits the 25th frame, it resets to 0 and then goes again and then every 25 it resets. Now if I hit play, now I've got a looping effect. The second thing is, how do we have more control over that distance? And we can do that by removing the divide and instead bringing in a map range. And what this does is it takes one range of values, in this case 0 to 25, and we can tell it to remap it to say take all of the values in that range, wherever they fall, squash it down to say 0 to 5, and it will relocate all of the values in between, so everything is a transition seamlessly. So cool. Let's so for that we've got the value that it's going to remap, which is the coming out of the modulo. Our minimum is 0. The max is 25. Let's add an integer, so another whole number. Put 25 in here. Let's connect it to the modulo and to the map range, so they're always tied together. Now if we hit play, by changing this max range here, I can actually adjust, I can change how far they end up moving on the z-axis. And let's definitely expose this value here. Drag off group input. I'll go back to my group tab over here, and I want to change it from float to integer, so a whole number, because we're dealing in frames. Minimum is 0, and we'll rename that loop length. Color code it so we can find it later on, and I'll connect that back to this map range. So now we can change it defaults to 0, so actually let's go to our group. Make sure the default is, say, 25, so we always see something. Jump in there, 25. Okay, so now you can change over how many frames the animation's happening. Now let's add some control to the animation itself. Our animation curve now still looks like this. Very linear, same speed every single time. What if we want to adjust the speed, so say they move slowly to begin with and then fast at the end and then start again, or burst out really quickly and slow down, or slow then fast and then they ease out at the end. Let's bring in a float curve, and float curves work between a range of 0 to 1, and if we drop that into our graph there, at the moment we're okay, we're taking our modulo and we're already mapping that to 0 to 1, so this should understand it. I will drag this out. You can think of the float curve as one of these cross sections. If we were to continue this on, this would be our graph here, our animation here. So let's create the first one. So slow at the beginning, fast in the middle, and then it tapers out. If you want to make sure that you see the values at the bottom here are starting to clip, if you click on that and hit auto clamp, you can see it may have been barely noticeable. I'll do the same for the first one, hit auto clamp, and it just makes sure that nothing is clipped off. Now fast at the beginning and slows down at the end. Let's try the second one, which is just slow and then speeds up near the end. We can even move this around to make it even more exaggerated. And the last curve, having them burst out at the beginning. We're going to take off auto clamp on the first one so it launches out and slows down. So now we've got something that can actually control the easing of our animation. But now we have the same problem of them moving a fixed distance, because this is 1 going every time. So just another map range node out the other end, and we'll take the from 0 to 1, and now this lets us dial in the distance the animation is translated to. I'll give that a lowish value, and let's expose that as another input. Let's call this max distance. Float is fine. I'll change the minimum to, let's leave, you can actually remap it to a minus, so technically if I was to take this backwards, they would move backwards instead of forwards. That's fine. Let's do 0.25 for now. these settings are okay. I just want to add a color to them. So for my presets, hit blue. I'll also change this to a slightly different color. Let's say pale purple, just because this is something we can adjust, but we can't expose it. Okay, now let's add some randomization. They're all moving in a really uniform, consistent way, all at the same. They're all moving the same distance in the same amount of time. So we can address that by bringing in another random value node into the graph. And actually, I'll just disconnect this for now, just so we can see how it works. So if I drag this into my max, what's going to happen is for each object, for each instance, it will get a different value out of this node, which means that each instance will move us a different maximum distance away. So now they're not all traveling to the same point. And to offset the actual timing of it, a cool trick is to just, before the modulo, so if we think about how the modulo is working, as it's just taking our timeline and then chopping that timeline up. So this number coming in matches the playhead here. So if we add in a math node, drop that in, we can add extra frames right at the beginning. So if I say 10 frames, for example, added onto the front of it, then the new timeline is essentially 10 frames ahead, because we've added 10 to the front. So when this is at 0 without, the one underneath, when we add it on, is at 10. So you can see it's 10 frames further forward. If we use a random value node in that input, so if I bring this over, plug that in, and say, if I add from 0 to the length of the entire loop, now each one of these guys has a slightly different start time. Now we're having the timing randomized and we're having the distance randomized. So let's reconnect the max distance. I'll reconnect it to the max range of our random value here. So now I can adjust that directly. As we're adding more random values to the same set of instances, we need to make sure we change the seed. If we don't do that, we end up with consistency across things. So everything that moves fast is also big, if they'll be using the same range of random values across everything. So rule of thumb, always change the seed on your random values. To make our animation a bit more interesting though, let's start scaling them. So at the moment we've got them, so they're moving away, and they're moving away. We've got some control over the curve effect, and we can just keep tweaking that to get a look that we're happy with. Let's now start animating the scale. So as they get further and further away, they get bigger and bigger and bigger until shrinking back down to nothing. So Shift A back to our instances menu, and let's bring in a scale instances. Because we want the timing matched up, we want, as they get further away, we want the scaling to line up with it. We can reuse all of this. Just bring in a new float curve so we can at least mess around with the animation a bit. Drag that in to value. Just make sure you don't drag it into factor. I do that all the time. Drag this straight into scale. Because this is 0 to 1, that's fine for scale. 1 being the biggest, 0 being nothing. And now when I hit play, as they get further away, they get bigger and bigger and bigger. But you can see they reset abruptly at the end. So what we need to do is drag this out a bit more. Bigger and bigger and bigger. And I want a drop off at the end. So now they're shrinking right at the very end. And what I may do is let's pick this and auto clamp it, so it will create this nice little toe for us. And depending on the look, you can just tweak this curve. But I think that's looking cool. I'm going to switch to render mode to see how that's looking. Start playing with the count maybe. Yeah, okay. And maybe the loop length. Maybe the loop length's a bit too much. Okay, I think that's starting to look good. At the moment, even though we're randomizing a lot of what's happening, we're still noticing the patterns in the animation. We have the loop, it's looping every 25 frames, which is only every second. And so we're recognizing the same shapes again and again. So the next thing I want to do is have it so that the shapes themselves randomize every few frames. And to do that, we'll go all the way back to this little setup. And this will work even if you haven't set up with an attribute statistic. And if you remember, we have our random value, it has its own seed, and as we tab through the seed, it will change what shapes it pulls from our collection. And if we plug in a scene time node, plug the frame just straight in, just to see what happens. Now we can see that each shape is changing every single frame. It's a bit too intense, so to control that, I'm going to bring in another math node and look for the snap operation. And all snap does is whatever's coming in this input here will snap it to the increment you set, the number you set in this second field. So now let's put it to say 10. And I'll just mute these by highlighting them, hitting M, and that will mute them from my graph. My count is, take it down to something smaller, to 10. And as I drag every 10 frames, it will change. This is snapping. Basically, this comes in and it's only snapping it to increments of 10. So as far as this is concerned, it's only getting a new value updated every 10 frames. So that's perfect. And now by changing this value, we can tweak the intensity. I think that looks good. And if we drag off of that to expose it, let's change it from a float to an integer, just so we're dealing with whole numbers, frame numbers. We don't need decimals, so switch to integer. And let's call this jitter. And now we'll go back, unmute these other guys. And it's defaulted it to 0, which is why we're seeing nothing. I'm going to default it to 3. Set these minimum to 0. And now if I put 3 in there, crank up the count. So now we've created something that has a whole variety of different controls that we can tweak. But if we were to duplicate this now, they're identical. So we need to be able to change the seed as well from our modifier stack so that we can create duplicates of these and randomize them individually. So I'll go back to the first seed back here where we used it on the collection and bring in a math node. So let's duplicate the snap and we can switch it to add. So the idea is that we will add on top of the seed value that's coming in here. Forgot to color code that. Blue. Duplicate it. Oops. Let's drag off of the add node. Another group input. Back down to our group settings, and we'll change this to an integer again. So whole number. Call that seed. Color code it. Blue. And I'll duplicate that along with this add node. Look for the next random value, which is right here. I'll drag that in, and then I'm just going to add any number on top. And this makes sure that we're not putting the same seed, exactly the same seed into every input. Duplicate again, let's find the next one over here. Change this again. And that's it. And now we can make each of our modifiers unique by changing the seed value. And if we tab back into render mode to see how it's looking and just start tweaking some of these values really quickly, just by adjusting some of the settings that we've created, we can make some really unique and interesting looks. Dial the angle up a little bit more. And now if I bring them together, I'll shift S to take my selected object to the active object. I'll shrink down the second one a little bit. And I think maybe crank up the max distance, take down the count, and pump the scale up just a little bit. Now let's bring the TV back to see how it all blends together. So I'm going to activate my TV for my outliner again. And so we can see the television in the scene. Let's add a couple of lights. I'll add an area light as my fill. I'll just angle that switch so we can see it actually appear. There we go. Rotate that. And I'll just adjust it just so it's giving me a little bit of a fill on the side of the television. And let's also add in a point light just to add a slight rim to the opposite side. And with a slight tint, it should work great. Cool. And the very last thing, just to tie everything together, let's go back to our compositor. So let's open that up here. Shift this across, and we'll search for a lens distortion effect. And a lens distortion simulates the imperfections you get with real lenses. So if I tweak the distortion effect, you can see it's giving it this fisheye. If you don't want these kind of grey areas around the outside, you can just check fit, and that will pin the edges. I actually don't want any lens distortion itself. I want to use this dispersion effect. So if I push that up, you can see as the image gets closer to the edge of the frame, it starts to separate the colours as if the light is passing through the edges of a bad lens. And to create the look of light kind of projecting out of the TV screen, that's perfect. And there it is, we've made a fully customizable animated visual effect using geometry nodes.